Hi, this is Shuai Liang, and doing the probability and the stochastic processing homework 5, and my net ID is sl5352, and here's my answer to the question 1 and question 2. Okay, the first question here is saying that x, y are independent with their probability density functions shows as two U functions, two step functions computational form, and given the z equals to the x plus y, and to find fz. So we could use a formula that is a convolution method given the first question that is here, and to compute just directly our convolution here. So begin with this question, I'm going to just write the formula again. That is fz equals to f x and fy's convolution, which is based on what is that? Based on z's convolution. So write the DOMI variables here, and to rewrite the formula here as an u of an alpha minus 1, blah blah blah, and so on and so forth. So using this, the basic idea here is to find the intervals between which are the integrated the polynomials get the values here. So just get a very important step here, which is just expand all of the things inside this polynomial and write expanded forms as here, and just find the intervals which is values 1, and in order to make the z is bigger than 1, so we multiply the u of z minus 1 at each one of the, this one is z is bigger than 2, so that they can be they can be uppercase of the interval, and this one that's the same, so we write a z minus 2 step function, and this one z minus 3 step function. So to compute all of these all together, and then we could write the final consequences here as z minus 1 u of z minus 1, and plus as not the subtract to 2 times of z minus 2 times u of z minus 2, and plus z minus 3 u of z minus 3. So that is basically the first way to compute the lowercase f z of the. Alright. So another way of compute this probability distribution density distribution function is that geometric method, which is to basically draw the coordinate and move the z upper and down, and to see whatever we get what we get from the uppercase of fz, and to do the kind of like what was that? The differentiate, or the just do the d things here. So let's do the second step here. That's the fz. We could write just the interval asked here is x is between 1 and 2, and y is between 0 and 1. So we could easily draw this kind of small regions here. So we move the z lines and up and down, so we could get the uppercase of a z, then compute the lowercase of z. So basically the first idea is that z is bigger than 3, which means that this line is above this shaded area and has no intersection with this shaded area, which means all of the shaded area are all possible, which also means that the uppercase of f equals to 1 when z is greater than 3. And when z line is moving downward, then I could get an intersection between this this square spaces and this line. So to compute this probability, we could use the geometric ways of that. So when z is between 2, which means here, and 3, which means here, and fz is equal to 1, that the total areas of this region, subtract of 3 minus z, which is this line's length, and the square and 2 over 2, which is this triangles regions area, and to subtract with that is a probability of z always this probability of z is less than this line, is under this line. So that gives much about the ideas how the shaded areas possibility are. So next step, we continuously moving this line down. The kind of like a different situation happens when the z line is crossing the diagonals here. It's down the diagonal actually. When z line would move down to here, which means z is between 1 and 2, and it's, using the same ways of computing the probability, the geometric probability that z fz, and when z is down this z line is z minus 1, which means that this length, and z minus 1 square over 2, which means this triangle's area, and then that is pretty much we need to know about fz. When z is less than 1, which means the line is moving down to here, and no intersection with this shaded area, so that means uppercase of z equals to 0. So we could write them kind of like an interval forms of uppercase z, then do the differentiate of the fz here is compute like this one. There's different forms of with the first ways of that is doing the convolution here, because I think that all of the impulse function here could be subtracted or divided by each other, so it won't make any difference with the first of these kind of like consequences you get from the convolution method. Should be the same method, but it's just can't be reached out instantly. So pretty much about the question 1.